Hi, I'm Saikat. I'm Apache Ignite committer and PMC member, and I have been part of Apache Ignite project for past 5 years now. And today I wanted to talk about Apache Ignite extension modularization projects. This is one of the project which we have been working for past 1 year, and we will talk about what this project is and how did it started and what were our motivation to move forward with this project. What were the hurdles did we face, and how are we looking forward to release these new projects. So to start with, the motivation for this project. So the core motivation for this project was to keep Apache Ignite core modules and extension modules to have separate life cycles. Few integrations which are no longer in use can be deprecated. So we took it as also an opportunity to look into some of the modules which are not very much used by the community can be used to deprecate and no longer need to be supported, and also help Apache Ignite community to support core and extensions separately. As we go through this presentation, we will see how do we differentiate those projects and what are the different modules do we have. So if you look into how Apache Ignite project is structured, it has a Ignite core modules where we have the main core APIs which are part of Apache Ignite project, and also we have some independent integrations. So the Ignite core modules contains memory centric storage, which is like in-memory data storage. For Apache Ignite, we have native persistence, which allows us to store the data into disk. And then we have integration with RDBMS, so you can use a PostgreSQL database as a also as a backup for your data store. If you're thinking like your memory storage is low and you want to persist your data into RDBMS, that can also be done. There are key values APIs, which is very similar to the cache store. So you can actually store a map, entry, and values. We will see some of the examples in the demo sessions today. And we also have SQL API, so we support NCSQL, and we have full support for the SQL APIs and syntax. We have compute grid and service grid, which are also part of the Ignite core, which allows us to run a compute instances of jobs and check status of the job periodically to see how that job is performing. We have a set of machine learning APIs part of the Ignite core, and we have capabilities to run continuous queries and support transactions. We have data structures and atomics, which are also part of Ignite core, and Ignite messaging APIs. So Ignite messaging APIs is something which we are considering to deprecate in Ignite 3.0 release, but we still have a Ignite messaging APIs which supports a queue-based data structure to store events or messages inside the Apache Ignite system. We also have core streaming APIs such as Ignite Data Streamer, which can be used to load data into Ignite nodes and can be used to stream data into Ignite cluster. We have logging framework. We have integration for Ignite Log4j and Log4j2, and those core modules help us to use any of the logging framework that we would like to use in our application. We have metrics and tracing framework. The metrics and tracing framework help us to see node specific metrics and see like what is the number of entries present in the cache, number of nodes are present in the cluster, what is the health of the cluster, how does it look like, what is the memory utilizations. So all of that are part of metrics and tracing framework. And we also have command line tools such as Visor and Control SH, which help us to get more statistics around the cluster health. So in addition to that, which are part of the Ignite core modules, we also have independent integration. So one of the example and popular extension or Ignite module is the Spark integration. And the Ignite Spark integration help us to use the Spark RDD in a way that we can actually modify the data inside the Spark RDD. Then we also have TensorFlow integration and Cassandra integration. So Cassandra integration help us to use a NoSQL data store like Cassandra as a backup data store. So in the previous one that I said, like we have something like PostgreSQL can be used as a backup or backup storage as RDBMS, but we can also use a NoSQL data store like Cassandra for data storage needs. So those are part of Ignite core and integration modules, but we also have certain set of more than a dozen Apache Ignite extension modules, which are primarily based around the data streaming as well as the data loading features. So what all of these integration allows us to do is that some of them are Apache projects and some of them are independent integration, but all of these third-party integration projects or extension projects help us to load or stream data from each of these extension systems to the Apache Ignite cluster. So few of them are like Ignite Flink, Apache Ignite Flink support. So Ignite Flink has two modules. It has like Ignite Sync and Ignite Sources. So in that context, if you are building an application, you can use Ignite Flink module, and then you can use Flink as a data source. While you are building a data pipeline, you can use Flink as a data source, or you could use Flink as a data sink. So if you're building a data pipeline, either of that extensions can be used to build a data pipeline, whether you want to use and store your data set into Ignite cluster, or you want to use Ignite as your data source and run some processing or jobs inside the Ignite cluster. So the next extension is also about Flume. Flume Sync extension help us to build data pipeline using the Flume configurations, and we can use that to store data into Ignite node. We have Twitter, ZeroMQ, and RocketMQ integration as well. So the Twitter is a extension which allows us to stream tweet feeds from Twitter and then store it into Ignite cache. The ZeroMQ and the RocketMQ are more of a message queue based integration, where we read from this message queue system and read those event messages, can store it into the Apache Ignite nodes. So these are some of the extensions are available. We have few additional, and we have some demos as well, which we will see in next session, like how can we use the Kafka streamers or Flink module as well. So we have Storm integration as well, which allows us to read the Storm Ignite tuple and store information into Apache Ignite nodes. We have MQTT integrations, which help us to read data from the MQTT streamers instances and then store them into as a key value pair into Ignite cache. And then we have JMS data streamer, which can help us to consume messages from JMS broker and store them into Ignite cache. And Kafka streamer is something that I'll be showing in the demo. Then it has also very similar use cases. So why did we consider to have Apache Ignite extension as a separate project? So the main core motivation was to simplify our release dependencies. So while we have been working on Apache Ignite releases, what we saw is that each of these Ignite extension modules has a dual dependencies. And by dual dependency, what I mean is that the Ignite extension module has a dependency on, for example, like Flink or a Kafka or Apache Camel or Flume in one hand. On the other hand, it also depend on Apache Ignite core, right? So if we have Apache Ignite core 2.8 released and we have Flink 1.7 released, then we are constantly looking into both side of these projects and then looking at what would be a good time to make a change, so that we are supporting the latest APIs of Flink and also we are compatible with the latest API of Ignite core. And this has been a constant struggle. For example, like in a scenario where Flink is making more releases, in a instance where I found is that we have been having this Apache Flink version 1.3, and there was a new release which came up as 1.5. We updated the version of 1.5 in the project and we released Apache Ignite, But by the time we made the release, we go through the voting cycle and made a release, we saw that new Flink version has came up, and then we are going through that again, that validation and release cycle to validate, like, okay, if the new Flink APIs are being compatible or not. On the other hand, there's another scenario where the extension projects are not going through any new releases, but Apache Ignite is constantly evolving. So in that scenario, what happens is we are releasing Apache Ignite. So for example, like we made a release from 2.7 to 2.8, and then we did not have any corresponding extension releases. So for example, like Flume did not had a new release, or Storm did not had a new release. But since all of these extensions are part of the core Apache Ignite project, we had to go through each of these extension modules and then had to update their versions, right? So we have to go and constantly change the POM XML and make sure that all of those extensions are updated to make and validated and tested against the new release that we are making for Apache Ignite. So that maintaining this dual dependency and for every release has been a large overhead for the release manager. So how does the release process in the current scenario looks like, right? So Ignite extension, as Apache Ignite grew over time and new extension got added to Apache Ignite, the project has grown to a larger code base, right? And we have Apache Ignite extension modules, all of them getting released with Apache Ignite core and main release branch. So we have a main release branch, and all of this extension, in addition to Apache Ignite core and Log4j and data streaming modules, all of them getting released together. And it's a large project, and also the work for the release manager to get validate the scope of the validation. This testing cycle is longer, and the build pipeline takes longer to release and get executed. So all of that increases the release time for us to make that change, right? So going forward, what we have decided as a community is to make sure that Apache Ignite extension is an independent module. And by that, what I mean is that Apache Ignite extension can be released independently, whether it is having dependency on Apache Ignite core, or it is having dependency on Flink, Flume, or Storm modules or Kafka modules. Based on that, each of those extensions can be released independently. What I mean is that now, instead of releasing the whole Apache Ignite project together with all of its extension, we can choose to release just the Flink module. So Ignite Flink extension will be released separate as a separate module as and when new changes comes in. Apache, so the Ignite Kafka extension will be released as a separate module as and when new changes comes in, right? If there are breaking changes in the APIs, or if we see that, okay, the newer version of Kafka is not getting supported with the new with the current Ignite Kafka module, then we will consider to update and make sure that that is compatible, and we will make a new release. But we don't have to worry about do we need to release the camel module, do we need to release the Flume module? All of that we don't have to consider. So what are the migration guidelines did we follow going through that process, right? So each extension, as I said earlier, like each extension can be released separately from Apache Ignite core. An extension has to be tested with the existing tools like TeamCity or Travis. So we should be using the same set of tools that we have been using to release Apache Ignite. Each extensions need to be validated with Apache Ignite core release, and some of the modules like Log4j or Log4j2, some of the modules that it kind of uses. So it needs to be validated against the latest release of those projects. And then extension can continue to have their own specific version. So as I said earlier, like Kafka and Flink will not be like 1.0.0 all the time, right? Kafka module can be at 1.0.3, while Flink can still be at 1.0.5, something like that. So each of them will be released as and when those projects independently evolve in their life cycles. So some of the migration risk also that we have considered. So we have a very large build pipeline, and we have like different modules which get validated. So modification of build pipeline as and when we migrate each of those modules from the existing Apache Ignite project to the new Apache Ignite extension project. We have to constantly, ensure that our build pipeline is green. We are making modification to those projects, and also looking into why the build failures are happening. If there are test failures, we need to ensure that the test suites are still passing with the migrations, and there are no breaking changes that are happening to the core pipeline. Then similar to that, the testing procedure also remains the same. We continuously monitor, like if the test suite has been passing previously, then all of those are green or not. If they are failing, then why they are failing, and constantly debug through those process to see like if migration has been the root cause for them, right? And we have those nightly builds which runs, and that gives us a very good metrics around if migration has been causing any of those failures and related changes that are needed to make sure that our build pipeline looks healthy and green. So the second thing was also the release policies. So since we have been moving around some of these modules which have been part of Apache Ignite project, so we had to also change our release policies, like when do we ensure or make changes to the documentation, how does the voting cycle looks like for releases, what are the modules that we are releasing could have impact with the migration process, and what are the compatibility metrics do we have. So if we have Ignite 2.9.0 release, we want to also make sure that we have a compatibility metrics where we can see, okay, Flink 1.0.0 is compatible with 2.8.1 and 2.9.0 and so forth, right? What are the new versions of Apache Ignite release can be validated with the current set of Flink extension or Kafka extension. So ensuring that we are making sure all of those compatibility are being validated also. So what are the benefits do we expect to get, right, from this large migration process? So one of them is like the faster release cycle. We should be able to release Apache Ignite extension quicker. So since we are now looking at a very smaller identified scope for release, so if we are looking at a Kafka module, we are just concerned about the changes in the Kafka APIs and the Ignite core APIs to make sure that, okay, we are able to make the release or not, and if we have to make changes into our test suites or not, or if there are any changes needed in the modules, and less overhead for release manager. So supporting more than a dozen set of independent integrations, and each of those projects are very different in a sense, like they have their own set of release cycle, they have their own set of integration process, and also the way each of the APIs for each of those projects looks like are very different. So for a release manager also to ensure that all of those projects are validated as part of the main core Apache Ignite project has been a constant challenge. Now, by breaking that dependency and making sure, like, we don't have just a single release manager who is looking at the whole Apache Ignite project, we will now have multiple release manager who can actually consider one extension module at a time and consider that scope to be released. And probably the release manager will be much closer to the APIs and the project itself, which will ensure that they are the subject matter expert while they are making those releases. So it makes like much easier for release manager who is making a release, and also the overhead for a release constantly becomes smaller and smaller, right? The individual extension module can be released independently. So we reduce the dependency from each of those modules, although they are quite independent, but they all had a dependency on Apache Ignite. But now, since these can be released independently, we have a much lesser testing scope in general and a validation scope in general to make sure that we can still go ahead with the release. And quicker testing cycles. Each of the extension module can have their own testing suites, so the testing cycle will be much smaller. So as and when we continue to release new modules, we can have a very small set of test suite that need to be validated against each releases. Probably the core as well as each extension module can be tested, and we can go forward with the release. So that reduces the scope of validation, as well as the testing cycle also gets smaller. So while we have been working through this migration process for past close to 1 year, there has been also new Apache Ignite extension being contributed from the community. So we now have a PubSub module which help us to has a streaming connector to inject PubSub messages into the cache, Ignite cache. And we also have Spring Boot auto configure thin and thick clients, which help us to use the Spring Boot capabilities and use Apache Ignite as a data storage system. So how does the migration looks like, or how does that upgrade process looks like from a user perspective, right? So if you look into the left side, the current Maven POM that we have the group ID as org Apache Ignite, and then the artifact is Ignite Flink, and the version is 2.8.1, which is the current version of the release. And then when we are releasing or moving towards the new extension module, we change the name from Ignite Flink to Ignite Flink extension. And the reason for that change is that we wanted to minimize the version conflict. So if we have like Ignite Flink extension, we can go back to version 1.0.0 and then continue to release, and then it will not conflict with the previously released Ignite Flink modules, right? So that is one of the reasons to change the artifact ID name, and the version can start from 1.0. So the context of each of these extensions can be used are very much towards the fact that all of these are data loading and streaming capabilities. They all some way or the other uses the Ignite Core data streaming APIs, and publish a set of events, unbounded set of events into the Ignite cluster. And the advantage of using Ignite is that the data get partitioned and distributed evenly across the Ignite nodes. The stream data can be processed in parallel, so we can, while we are publishing more and more events into the Ignite cluster, we can continuously also run our jobs to run continuous queries to see or get metrics around the systems, or get more data, live data sets results as well. To know more information about this project, you can visit the wiki, IEP 36 modularization. It has the complete information about the project and how did we move forward, what were the discussion threads we had, and what was the reasoning for this project. And with that, I'll move towards the demo section now. So we will look into 3 different examples of these extension modules, and also a native use of the streaming APIs. So the first example that we look into is the stream words. So we have 3 different examples in the demo, and each of them actually move in a level of complexity from using the data streaming API natively to a point where we are using each of these extensions. And I'll share some of the context around how these APIs can be used, and how you can build a application using these extensions. So the first one is stream words. It's a very simple function. So we have function main, right? And what it does is that we start a Ignite instance and we set it as a client mode. So we will start the Ignite as a client instance, and we will instantiate the Ignite cache. So we will Ignite, here we are doing a get or create cache, which means like either you get the cache with this name, or you create that cache if it doesn't exist. And we also have certain configuration. So we give a expiry policy of 1 second. So the cache, the entries that will be present in the cache have a sliding window of 1 second before they expire. And we are reading from a text file. It's a very simple example. So we are reading from a text file, and we split the words based on white space, And then if the word is not empty, we generate a key using UUID, random UUID, and then we just add the data into a Ignite cache. And here you could see that I have instantiated a Ignite data streamer instance where we are saying the data type that it supports is the key is the UUID, and the value that it supports is a string, and we gave the stream cache name which we created here. And that is that. So what it means is that it will read the text from the file, it will break them up, and then it will store it into the Ignite cache as a key value pair. So let's start on this example, and to do that I'll just start an example node here. So this starts the Apache Ignite in server mode. As I said, like the example uses the Ignite in a client mode, so we just started a Apache Ignite server to publish the data. All right, so server started, and here we have the streamer API example. And here you could see that we are using the data streaming APIs which Ignite provides. There is no extension involved in this specific example. So we run stream words, and it started publishing the data. And if we see the instance here, you could see that, all right, we started getting some data which is constantly getting published into these cache words, and the key is the UUID which we generated, and the value is set of events of streams of data, unbounded stream of data which is getting published, right? So with that, this shows the how you can use the Ignite data streamer APIs natively, so you don't have to depend on any of these extensions. And then we will see how depending on each of those extension actually makes your application more close to a production ready app. So I'll stop this example. So we stopped these, and we will see the next example is the Kafka streamer. All right. So the Kafka streamer is now in this example we started depending on the Kafka extension, and we will use the Kafka streamer to publish the data, and we will be reading it as from the Kafka message broker, break that events into messages format that we can understand, and then we will publish it into the Apache Ignite node. So you could see the function here, consumer stream. So consumer stream just read it from the cache, test cache, and then it reads the information from the topic. We given a topic here, and then we start the Ignite instance. Here we are starting the Ignite instance as a server. So just to keep the example simple, we are just starting the Ignite instance as a server. We do the same function get or create cache that we saw earlier, like we are creating or getting a new cache name. Then we set the streamer, we get the Ignite data streamer instance, and here in the streamer we say allow override or auto flush frequency. So these are some of the functions which allows us to do specify whether we want the value in a key to be overwritten or not. So if the streamer allow override is set to true, which means that for a specific key, if it come later in the event stream, the key value of that key can be allowed to be overwritten. And the auto flush frequency means like how frequently do you want to publish this message from this specific example app to the Ignite node. So here auto flush frequency 1 means every 1 second it will be flushing the data. Then we instantiate the Kafka streamer, and we set the Ignite instance to the Kafka streamer. We also set this streamer, Kafka streamer instance with the instance of the streamer we have defined here, data streamer instance we have defined earlier, and we set the topic for the message, just, and then we set, okay, we just want single threaded application, so we can set it as 4 or 5 depending on number of resources or number of threads you want to define or specify. You can define a set of number of threads, and if you choose to run it in parallel. Then we define the consumer config. We give the broker address localhost 9092, and then we give a consumer group ID. And here we are also setting a multiple tuple extractor, and these are actually stream adapter functions we have in the core Ignite project. And what it allows us to do is that we can choose to have a set of entries to be published altogether into the Kafka, from Kafka to the Ignite node, or we can choose like each entry to be published. So we have two variation of that. We have multiple tuple extractor or single tuple extractor, depending on your need and how the data volume looks like and how frequently you want to publish your messages. The size of the data you have in your messages can help you to decide whether you want to use the multiple tuple extractor or single tuple extractor. So in this example, I have used multiple tuple extractor, and for each record as I read, I'm storing it in a entries map, and then all of that will get published, and we start the Kafka streamer here. So to start this example, I will start the Kafka instance. So we have the Zookeeper and the Kafka server up and running, and we'll start this streamer. So this starts the streamer, and we will see. So you could see that it started one of the instances, and now we will start the terminal. And I have a simple data publisher API, which it's a very simple example for a data producer written in Python. And what it does is that it just publishes, reads a text file, and then publishes the data into the my topic, Kafka topic, from which we will be consuming right now. So this instance is running, and let's see how it looks like. So this was the previous example. Now here you could see, like, we started getting a stream of events, which is the UUID is consider this more like an example where you are reading clickstream, right? And each of these values are kind of like item product ID or SKUs, and then the key looks like are more like a visitor ID. So you getting a clickstream data from your production app into your this streaming application, which is getting you the visitor ID as well as the SKUs which are getting ingested. So basically this reflects how this specific image looks like, right? Instead of Apache Flink, we are using Kafka streamer and publishing the data into the Ignite nodes. And if you want to run more a separate set of jobs, you could actually have another application written, and in that you can use Apache Ignite in a client mode and run certain set of compute job to see or aggregate the results of your clickstream events, or gather metrics around your application in general. So this just shows, like, how we can read from a Kafka broker a set of events, unbounded set of events, and publish them into the Apache Ignite node. So the third example that we will see is even little bit built on the learning of this Kafka streamer, and there we will use Flink and show you like how you can use a Flink extension to do certain amount of different set of stream processing while you publishing the data into the Ignite nodes. So I'll stop this example. and let the data producer continue to produce that data. We will go to the next example. All right. So just to show the dependencies that I had in this project are Ignite Flink extension. As I said, like, if we are migrating to Ignite Flink extension, this is the change that needed in the artifact. You could see also Ignite Kafka extension is also one of the dependency we had. And here I have defined 1.0.0 snapshot because this is all locally built. We have not made the release yet, and we are preparing ourselves to make the release. So the snapshot will go away, and we will just say it as 1.0.0. So the example that I have here is the stream window item count. And this example is something where we want to see if we can get a set of events for items which are getting sold in a retail web, and we will see which is our top selling item, right? And these give a context of within a set of 10 seconds which is our top selling product. So one of the core distinction that I wanted to call out about between a streaming application and a batch processor application is that in batch processing application, the data set is always considered to be bounded in number of records we have. So we will say something like, in our conversation, we say like, okay, we have like 4 million records, or we have 10,000 users, or we have a bounded set of numbers that we say to define the data set or the volume of the data. But in case of a streaming application, we also add one more attribute or one more dimension to that, and that additional dimension is the time, right? And we say like, okay, what is the velocity, or what is the order volume per hour, or what is the number of visits per every 30 seconds? How does the metrics looks like? Or what is the sale volume last year, or what is the sale volume last month? These are the kind of we add this additional dimension to that query that changes the streaming application context with the time window. And that is a very interesting area, right? So when we are considering a streaming application, we are always also considering one additional dimension of time when we are discussing about the metrics or result sets. So now we will look into the Flink example here. And here, this is very similar or kind of considered to be built around on top of the Kafka streamer, but there are some additional changes in this one. So to use the Flink extension, what we have done is that we have defined this Ignite sync, and in the sync function, we just provided a properties like we want to instantiate a Ignite node, and we set allow override to true. So we allow the keys or the data key to be changed, the value of the data key to be changed, and then the flush frequency here we defined as 5 seconds. So every 5 seconds the data will be published from your application to the Ignite node, and we start the Ignite sync here. Once we get the Ignite sync instantiated, we create a stream execution environment. So the stream execution environment is more of a sandbox kind of environment which allows you to execute your application. So the stream execution environment abstract away the fact from the developer that whether the application is running in your local laptop or whether it is running in a data center with hundreds of machines or hundreds of nodes being part of your stream execution environment, right? So we get this execution environment using this function, and then we say, okay, get a text stream of information. So here we are saying add a source. So in a streaming application, we basically have a source and a sink, and then we have the set of functions that we apply to those data which has came into this, right? Came into the application. So we define the source here, and we define Flink Kafka consumer. So here we defined a Kafka consumer as a data source to get the data. We get the topic, and when we get that text stream, on text stream we apply a flat map function. So this is the this is a bit different than the previous Kafka example where we were just reading and publishing the data by storing it into a hash map. Here we actually, on an incoming stream of events in the runtime, we are applying certain function, right? So we apply a flat map function and we added a splitter. So the splitter is also very similar to the streamwords example that we have shown. So it reads the set of text and then split them based on white space, right? And then give you a set of word and the number of time it has appeared. So if hello comes twice, it will say like hello too, right? So that splits the word and give a count of times it has came. The second function we apply here is the key by function. What key by function allows us to do is that given a set of words in the text or a stream of events, you can partition the data based on that key. So hello 2 becomes the key, because here we are saying from the tuple, the first element of the tuple, which was the output from this splitter function, you could see tuple of 2. This is the first element and the second element, and on this tuple 2, when it arrived, the next function, the key by function, applies on the tuple of 2. On the first element, it partitions the data. So now your data came in tuple of 2, and then it started getting partition in the key by function. Now in the third function, what we applied is that we apply the context of time. So we say like time window, time 10 seconds is the context within the event window when we want to consider that operation. So it means that if I'm doing an aggregation, I will consider an event window of time for 10 seconds, and we will apply the aggregation in that 10 seconds. Or we could change it to like a minute or 30 minutes or an hour, depending on how we want to aggregate the data. But also we have to ensure that since this application is running in the runtime, the larger the time window is, which means that your application is aggregating or operating all the events which is coming within that time window, and it also increases your memory requirement. So your it determines, like if you are considering a time window of 1 hour, then in an hour all the events that has came in need to be stored, to be able to be stored in the memory of all the nodes which are present in the cluster, and we can do an aggregation of that. Within that, the smaller the time window is, the memory requirement of your application grows smaller and smaller, right? So within that time window, we apply a sum function. So here we are doing a aggregation. So we got the key and the value, which was an integer. So we start now getting applying that sum function based on the second element in the tuple, right? And then the last function that we apply is the formatter. And the formatter function, just that it just formats into a key value pair which Ignite can understand. So Ignite cache, as we defined it as a string and integer, it will start understanding that key value pair. So if you see, like in Ignite Sync, we have defined a map of string and integer. So we formatted the events which has came in, and we defined, okay, the tuple has a string and the integer as a second element. We've just formatted them into a map which can now be flushed into the Ignite nodes. And here in the last function, to this window count, to this stream of events, we also add a sync. And here what we did is that the instance of the Ignite sync we defined earlier, we added that as a sync in this application, and then the final was the environment.execute, which means that we will start this application now. So to start or visualize this, see this application running, we will start the Flink cluster as well. So we started the Flink cluster, and we'll go back to our dashboard. I had some couple of jobs running previously which have been stopping them, so those messages are coming in. So right now we have available one task slot which can now start accepting a new job, and we will start the application now. So this starts the job of stream window count, and you could see like, data already started getting published. You would see, okay, records, bytes being sent and record being sent, which are getting received. And it started already processing the application. So we will go and see the example here. You could see that data format will change here. So now in this example, what we have said before is that, this is more like every 10 seconds you are counting what are the items are your top selling, right? So you could see like, okay, all of these SKUs or the product IDs are almost selling at the same rate, because it's reading from the same text file and then publishing those events. So that's why it's not much of a different though. But if we keep refreshing, you could see like still there are like, depending on when the data is being aggregated, we could see some differences here. So this shows like how we have used each of those examples, and starting with the core Ignite data streaming API, using those to a point where we started using a Kafka streamer and started reading those events and publishing them directly to the Ignite node cluster. On top of that, we also have seen Apache Ignite Flink. How can we use Apache Ignite Flink and you apply some of the data streaming APIs or functions to the incoming stream of events and process them and store it into Ignite nodes to our needs. So these are like three variations of extensions examples that we have seen. And I think with that, I'm open for questions now.
Okay, Saikat. Let's see, we have a question. Where should we run Flink job? Ignite client node, or is it allowed from outside the cluster?
No, it is allowed from outside the cluster. So yeah, the way you will be building the data pipeline would be, you have a Kafka message broker, and you have your Kafka consumer apps which is running. Then, and when you're running your Flink job cluster, you will have a separate Flink job cluster which will be can be used. So if you have seen earlier in my example here, I'm running it as part of here I'm using Ignite and Flink together, but you can be using Ignite as a client node and can run in a way that your Flink job is running in a separate job cluster and publishing using the Ignite client, Ignite in a client mode to a separate cluster of Ignite server. So to simplify, in the example, I've used Ignite inbuilt in there as an example, but in real world production ready app, you will be using all of these separate components of your projects in a different set of cluster. And the advantage with that is that you can basically scale up or scale down depending on your project needs. So if your project need is of a data size is very large and you need a larger cluster of Ignite nodes, you can have that. Or if your data volume is low but the frequency of data streams are very high, then you may need a large job cluster for Flink. So that's how you can change or scale up or scale down each of those clusters.
Okay, thanks everybody for attending. The next sessions begin in 10 minutes.
Thank you.